I'd like to talk to you about the lithology of the park. But to do that, we're going to have to travel back in time to the Triassic, when most of these rocks were put down. Now, first of all, the Triassic, this area wasn't here. It was closer to the equator. How did it get here? The only thing that could have brought the land here, plate tectonics. A few inches at a time make a difference. It was a tropical climate, subtropical that is, wet, and to the south and the southeast there were mountains. To the west there was an ocean, and the area that makes up the park was a fluvial plain. There were rivers draining off of the mountains and rain and water heading towards the ocean. And so this rain and rivers were bringing sediments down from the mountain, gradually eroding them away and depositing the rocks here in this plain that are what we see in the park today. There's a wide variety of rocks. There's small sizes, the mudstones. We had bigger sizes, clay stones, sandstones. There was mixtures of rocks like conglomerates, and we even have bentonite. It's a clay that swells. I'll talk a little bit more about that later. But why are there Triassic rocks at the surface of the planet? Where are the rocks that came after that? Well, this is an unconformity. So what happened 60 million years ago. To the best of our knowledge, rocks kept on accumulating, but they've been wiped out by the Colorado Plateau. 60 million years ago, the Colorado Plateau was born. It's a large area, thousands of square miles, that covers most of 4 states down here. What was happening was there was a continent here, and there was an oceanic plate subducting underneath it. But instead of the steep dive that subductions tend to do, it was more a horizontal dive and was pushing the Earth up. That, combined with another theory that says a big chunk of this subducting plate broke off, and by big chunk I'm talking thousands of square miles, hundreds of miles this way, hundreds of miles that way, broke off, and instead of subducting, floated up. It floated up because it was less dense than the rock that was around it. And what it did was it pushed up the rock that was over it. And it pushed it up a lot. We believe it pushed it up almost 10,000 feet. That's almost 2 miles. Well, what happens to rock that's pushed up 2 miles? It's the new mountains, right? And then they start to erode. The elevation of the park today is between 5,000 and 6,000 feet. So we've lost 5,000, possibly 5,000 feet of rock and lots of geologic time. So we have an unconformity. But it exposes for us the Triassic rocks.